right, welcome, welcome. We're going to get started here right on time, 12:15. Thank you all for coming and thank you for stopping your discussions. I'm Teresa. Good to see you all for our first external speaker this semester. We have a few announcements to share this Friday at 12:15 at the workshop. We have our All About Data Visualization workshop with Jeffrey Moss from the Humphrey School of Public Affairs. So please join us right here in this room to learn about data visualization. Okay, now it's my pleasure to introduce Braden Rothy, who is a graduate student in the Department of History and an ISRD trainee in Population Studies, who will introduce our speaker today.
Thank you. Um, yeah, so I have the honor of introducing Dr. Kelsey Best. And Kelsey Best is an assistant professor of urban climate resilience and adaptation disparities in the Department of Civil Environmental and Geodetic um, engineering at The Ohio State University. Dr. Best holds a BSE in Chemical and Biological Engineering from Princeton and a Master of Science and a PhD from Vanderbilt in Earth and Environmental Sciences. She'll speak about some of the research that came out of her dissertation, which is titled The Dynamics of Environmental Change, Livelihoods and Migration in Bangladesh, an agent-based modeling approach. And I should note that she has a new book out titled Migration and Displacement in a Changing Climate. And her talk today is about modeling climate related migration in coastal Bangladesh. Oh, and I forgot this last time. I'll forget it next time. We have a mug, a speaker
Oh,
mug. There you go.
thank you so much.
Yeah, of course. Unfortunately, you can't take it with you, but it'll be shipped to you.
Okay. Then I will put this back here. Okay, great. Thank you. Just a little mug teaser. I like that. Thank you, Braden, and thank you all so much for having me. It's my first time in Minnesota, and it has been a pleasure to be here. So I'll just get started. I think Braden covered a lot of this, but I usually like to just share a little bit about me and my journey, especially for any students in the room, because I did have a bit of a windy path to get where I am now. I did major in chemical and biological engineering. I actually worked in corporate sustainability at a large company after that for about 2 years. Went back to grad school in earth and environmental science, did a postdoc in civil engineering, and now I have a joint appointment in civil, environmental, and geodetic engineering and city and regional planning. So I'm in two departments, neither of which I have degrees in, which has been a lot of fun and I think speaks to really how interdisciplinary my work is, and I try to do my work. And then outside of research, I enjoy really anything outside horseback riding, gardening, hiking. These are my two fur babies. That's Henry the dog. He's a 12-year-old super mutt. And that's Danny the cat. And we have a new member of the family now, Pepper. She's a corgi mix who's not featured here, but I'm happy to show you pictures after the talk. So, just high level, my research has kind of broadened from what I'm talking about today, which is migration in Bangladesh, to now focus more on how climate change broadly interacts with human well being and infrastructure systems, how communities can adapt to those effects of climate change, and I think most importantly, then how can adaptations be designed and implemented equitably? So, I think a lot about social vulnerability, equity, and climate justice. So, as I mentioned, I enjoy working in interdisciplinary teams, interdisciplinary methods, though most of my own work is currently quantitative. I've been dabbling in a little more qualitative work that I will touch on, but really under this framework of climate justice. So, who experiences the effects of climate change and who has access to resources to respond and recover? All right, so let's get into the topic of this seminar. So, my dissertation was focused on climate related migration. And I'm sure many of you have heard about the ways that climate change can impact migration, either in research or just in the popular media. So, these are just some headlines that I pulled a few years ago, but they're still, you can Google search and see more up to date headlines. But what we see here, I just Googled climate refugees or climate migration. You'll see headlines like, what are we going to do with 200 million climate refugees? How bad will climate migration get? Language about floods of climate refugees, climate fears, and relocation. So, really, there's this kind of alarming rhetoric around climate refugees and climate migration. But what's important is if you just look at this popular media, it really conveys this idea of kind of a straightforward linear relationship. Climate change effects happen, or a climate related disaster, and people move in mass, right? That's kind of the narrative that is out there in a lot of cases. In reality, it's really complicated. So, anyone who has moved at any point in your life, you know that the decision to migrate is ultimately an individual or a household level choice. Your two options are to migrate or to stay. And that decision is influenced by your own individual characteristics, but also your family, maybe your job, education, etc. In addition to that decision that's influenced by those really micro level factors, the decision can also be influenced by macro drivers, so higher level dynamics that vary across spatial and temporal scales. And this can include environmental conditions, political circumstances, social norms, social networks, demographics, of course. Economics are very important as part of this. So, within this complex decision making context, environmental change or climate change can operate by influencing these other dynamics. So, most often, it's an indirect effect via economic or social, political conditions rather than that direct linear effect. So, this is the complex context that we're working in. And as I mentioned, of course, it's also very personal. Migration does come down to those individual decisions to move or to stay. So, as I was doing a lot of my work in Bangladesh, and I'll talk about the modeling that I did, I used machine learning, these complex quantitative methods. It was really important for me as part of that work to also ground what I was doing in the lived experiences of people in this context. So, I actually got some internal funding from Vanderbilt, where I did my PhD, to just collect people's stories. So I collected stories from 10 climate migrants living in Dhaka in Bangladesh, and these stories were incredible. So this is one of my favorites. This man, Anisor, describes how he was a fisherman in his rural coastal village. He was caught up in a cyclone while he was out fishing. He describes kind of making his way to shore in a barrel several days later and eventually finding his way home. His family thought that he had passed in the storm, and he found that his home had been destroyed. So, after all of that, he made the decision to migrate to Dhaka, the city, to try to build up savings, earn more money to eventually go back home and rebuild his home. So, when I'm modeling, I'm also thinking about people who have these really incredible stories of this kind of climate related migration. And so these stories are available. This is not peer reviewed or published, but their stories are on an interactive story map that is linked here. Okay, so I'd like to take you to Bangladesh. Has anyone been to Bangladesh? Okay, nobody. Okay, has anyone studied Bangladesh? You have a few. Okay, great. Then I'm happy to take you to Bangladesh with me. So, this is the country of Bangladesh. It is a very dynamic natural landscape. So, there are three major rivers. We have the Ganges, the Brahmaputra, and the Meghna. And those river systems, you can see them kind of weaving and braiding north south across the country. They converge and ultimately pour down here into the Bay of Bengal. These are massive river systems that are constantly eroding and accreting the landscape of Bangladesh. So it's actually estimated that these rivers annually pour about 1 billion tons of sediment into the bay. So this is massive amounts of land that are being moved and shifted. Also, when we think about Bangladesh, Bangladesh is considered one of the most climate vulnerable countries in the world. So it experiences things like salinity encroachment with sea level rise, frequent and increasing intensity cyclones, especially around the southern Bay region. It also has a monsoonal climate, so there's annual seasonal flooding and waterlogging. And then, if we think about the social dimensions of Bangladesh, especially in some of the areas where I work, which is around the Southwest, it's highly agricultural. So, a lot of rice farming, recently shifting more from rice to aquaculture, so shrimp farming. It's also one of the most densely populated countries in the world. So, to put it in perspective, the population of Bangladesh is about half of that of the United States in an area that's similar to Louisiana. There are a lot of people in a relatively small space, and as I mentioned, a very dynamic environment, which makes this a really interesting place to study environmental migration. So, then thinking about migration in Bangladesh, there are active migration patterns throughout the entire history of the country before Bangladesh was actually Bangladesh. These are primarily migration patterns following economic opportunity. So there's a lot of rural to urban migration, especially seasonal migration for livelihood diversification. So within this context, again, we don't think about kind of not immobile populations experiencing environmental change and then moving. We're really more interested in how these existing patterns of a highly mobile population are influenced by environmental stress. So, then within this context, we can also think about migration as potentially an indicator of a system failure. So, something went wrong, there's desperation or a need, and people are pushed to leave. But in some cases, it can actually be an active adaptation strategy and an active way to build resilience. Remittances are highly important in this context, so sending money back home. And if you visit some of these rural communities, you can actually almost point out the homes that do have migrants because you can see significant differences in just the stability of their homes. So they can really help to strengthen home communities. Another thing I like to mention is, as you can imagine, with the population density, many of the urban areas in Bangladesh are very strained. The infrastructure is stretched thin. So this is a informal community, really in the heart of Dhaka, the capital city. This is the Karal slum or informal settlement that I have walked through. So all of this is informal housing. People access electricity by kind of tapping into main lines. There are not water services, and there are hundreds of thousands of people who live in these kinds of informal communities. So I was very lucky. And when I started grad school, I came onto this project that was a large interdisciplinary project that was looking at environmental migration in Bangladesh. And there were professors who'd been working in Bangladesh since the 90s. We had natural scientists, social scientists, like psychologists and political scientists. And I was really working right in between those two groups. And so when I came onto this project, we had already gone through the effort of collecting household survey data. So, one of the major parts of this project is called the Bangladesh Environment and Migration Survey, or BEMS. There's been two phases of this, and they are actually in the process of doing a third phase and trying to track migrants over time. But the purpose of this survey was to capture migration histories at the household level. The survey collects much more information than that. So it asks about livelihood, family structure, even some environmental perceptions questions like, does your water taste funny? Have you noticed changes in your water taste? So this is a very large data set that consists of about 2,000 different indicators. And in the first phase, which is what I really focused on, this was across 9 communities, and you can see close to 2,000 households as well, with about 3,000 individual respondents. So I came into my program and was basically handed this incredibly rich data set of household information. So the first thing I did with this data set as kind of a new scholar is, as I've laid out for you and hopefully convinced you, environmental migration is very complex. So I wanted to start by trying to just identify the important predictors of our migration outcome within that household data set that we had. So I used a machine learning approach called a random forest algorithm that can help us just identify from all of those variables in our survey what statistically is most important for predicting migration. And so what we see here from top to bottom is those 15 most important variables out of that close to 2,000. And what we saw here is, in this context, we did see some environmental indicators stand out. So we saw latitude and longitude, and this was even controlling for the community, which we think could be coding for something environmental. So especially north south, we have salinity along a gradient. East west might be proximity to the capital city of Dhaka. And then we saw some questions standing out about cyclone experiences and specifically access to services like food and water after a cyclone. But we also saw a lot of non environmental indicators emerging at the top. So, specifically, economic indicators like whether or not the household owned its own business, and if so, what year did that business start? And then things like whether or not the household had a gas or kerosene cooker, and whether or not they had a refrigerator, which in this context would be an indicator of a certain level of household wealth. So I'll back up for a moment. So, what this exercise did is it showed us what was important, but it doesn't really tell us much about why these things are important or how they're really influencing the dynamics of migration. So, from there, we decided to use a new method, a different method called agent based modeling. I'll do another show of hands. Has anyone done agent based modeling? We have some. Cool. Okay, great. So, agent based modeling, this is a simulation model approach where you have individuals or agents. Those individuals have their own set of characteristics, and importantly, those individuals make decisions. Your agents can exist within a dynamic environment that they can interact with. That environment has its own set of properties and changes. And you can also have agents interacting with one another. So they can have networks where they exchange information or resources across those networks. And what we're interested in with agent-based modeling specifically, is how the behavior of all of these individuals contributes to higher system level dynamics. And this is what we call emergence in the context of agent based modeling. So, when you have a bunch of individuals interacting with themselves, with each other, with their environment, what happens at the system level? And I will share within the broad field of agent based modeling that has been applied to many different contexts, there are two somewhat competing philosophies of how this should be done. One is the keep it simple, stupid, or KISS model, which says keep the model as simple as possible to capture the important dynamics that you need. You don't need to go overboard, you don't need to add more. The other side of that is enhancing the realism of simulation, which says we should be continuously trying to get our simulations as close to reality as possible. So, adding more complexity, adding more factors to try to increase the realism. It's not clear which is the best approach or in which context for what kinds of problems. This is active debate. So I'll come back to that in a little bit. In the context of environmental migration, there are a few agent based models in different contexts. This is a 2018 review paper that found 15 different models. Um, I would say there are probably a handful more, mine included, since this came out. And across this review, there's a wide range of modeling approaches, variables, scales, even outcomes that are investigated, really just a lack of consistency in what those models are looking at, and all different decision making as well, which is really a key component of agent-based modeling. And then very few of these models this review found actually included the coupling between the human decision making, the social system, and the environmental system. So this figure shows kind of a breakdown of those papers. All of them included the origin, only 8 included a destination. Most are looking at out migration rather than return migration, and a few have agents just leaving in or out of the system. So, really, to show you the broad range in these models. So, I sought to develop my own agent based model of environmental migration in Bangladesh. And I started with this first question of, can a simple economic model reproduce known patterns of environmental migration in Bangladesh? So, starting with that keep it simple, stupid approach, a very simple utility based model, do a good job of capturing known patterns. If so, what combinations of different parameters and variables within that model would contribute the most to being able to reproduce those patterns? From there, I also did want to kind of play with adding more behavioral complexity. So I wanted to create a flexible model that allowed me to change that decision making approach relatively simply and see how different decision making frameworks might influence the migration that we were simulating. And again, under different decision making frameworks, what are the important factors that are influencing those dynamics? So let's start with that first research question, which is our simple model, an economic based, agent based model. And we used what is called a pattern based approach. To our knowledge, this was the first time that a pattern based approach had been used for an agent based model of environmental migration, but it has been used in other contexts. The idea of the pattern based approach is that if our model is able to reproduce multiple known patterns of the dynamic of interest, then we can feel more confident that we're really capturing important dimensions of what underlies that process. So we identified 2 patterns that we sought to reproduce before we started modeling, and these are from the literature. And so the first, what we call pattern 1, is that in Bangladesh, there's evidence that when a natural hazard did strike a community, there was a nonlinear migration response. If only a few households within that community were affected, initial outmigration would decline. Above a threshold of about 20% of the community, that migration would increase. So we had this community level nonlinear pattern that we want to reproduce. And then we had another pattern that was more at the household level, which is that there was evidence that households themselves that were not impacted by a natural hazard were more likely to migrate. So a household whose community was impacted, but they themselves were not, had higher mobility. So again, our argument is that if we can reproduce both of these patterns consistently, we can feel more confident in our model. This is essentially a validation approach. So then we had to make the model. And what we did is we had this kind of nested structure. So we had agents representing individuals. Those individuals were positioned within households. And then at the household level, that's where the migration decision took place. And that was consistent with our understanding of the context in Bangladesh. So the household would decide whether or not to send an individual as a migrant to the city. And they would do that by assessing a village economy where there were agricultural and non agricultural jobs available. The agricultural jobs were impacted by the environment, and we could simulate a stochastic environmental shock. It was representing a drought in this case. Richer households could hire others in the community to work on the farm. And if that household itself was impacted by the environmental shock, they could not hire others and they would seek employment elsewhere. So within this economy, individuals would look for employment or the household would decide to send the migrant. So here's just another way of looking at how the model worked more kind of sequentially. So at the start of each step of the model, which simulated about a year of time, we would have an environmental shock that could occur, and we could change the degree of that shock, so how much of the community was impacted. The employment opportunities within the market would be updated. Individuals would then seek employment within that labor market. Households would calculate the utility of their individuals, kind of take stock of everyone in the household, and based on a utility calculation, decide to send the migrant or not. And in an ABM, we can repeat this process for as many steps as we specify. A challenge with agent-based models is that the more variables you add, the more you need to find reasonable estimates to parameterize those variables. So we had some of these key variables like a wealth distribution, household size, land ownership, age, etc. Many of these variables we could find estimates in the literature. So this Adams was a data set that was publicly available, and then Carico and Donato is from our own BEMS data. There were two key factors in our model that we could not find good estimates for, and they were really important variables. So one was the cost of migration, and the other was the benefit of migration. And so these were really critical to our utility calculations. And there was not data for that. So without data to find estimates, we decided to use an approach of just searching across a wide parameter space. So we used what's called a Latin hypercube sampling approach, and you can see we have estimated cost of migration in Bangladeshi Dhaka, estimated utility, and we could sample each of these dots as a unique combination of cost and benefit that we could then run in the model many times and evaluate to see if that combination of parameters could reproduce those patterns of interest. So the orange dots mean that that combination failed at reproducing our patterns. The green dots were successful. The shading is a support vector machine model just to kind of predict across the entire space if we think that combination would be successful or not. So this was our first attempt. What you see, we had, you know, about half of the parameter space could predict pattern one or reproduce pattern one. About half could reproduce pattern two, but they did not really overlap. And if we looked at both patterns, the model really didn't do a good job. We have one green dot there. The parameter space is very narrow. So we were puzzled. I share this in part because research doesn't usually work the first time. So we went back to the drawing board and went back to some of our key variables. And we really honed in on the way that we were looking at community level inequality in the model. So we had been using just a simple normal distribution, which was not actually capturing the potential dynamics. So we switched to a low max distribution for our measure of household inequality. And for this, we can use a Gini index, which I'm sure many people are familiar with, very common measure of inequality. I'll just remind you that a Gini value close to one means more unequal distribution, so more resources in the hands of fewer. So we updated, again, based on our BEMS data, switched to this low max distribution, but we were actually able then to change this and compare the Gini value from our BEMS data with a little bit of a sensitivity analysis around a higher level of inequality or a lower level of inequality. And very interestingly, we found that when we got that measure of community inequality closer to right, our model started to do a much better job of reproducing our patterns of interest. So now this is our parameter space, again, with cost and utility Again, the orange is the failure, green is the success. This is for both patterns. So we found that this space dramatically increased. And actually, we see that the model was no longer very sensitive to the cost of migration and much more sensitive to the utility. So here's what this looks like for our Gini coefficient based on our BEMS data. This is pattern one. So if we change the degree of the community that's impacted by our environmental shock, as we expect, we see that initial decline in migration and an increase as that level of community impact goes up. We could look at pattern two as well, now dividing our households across those that were not impacted by the environmental shock versus those that were. And we see at some of these higher levels of impact that, in fact, as we expected, those non impact households had more mobility than those that were impacted. And so, as I mentioned, we did a little bit of sensitivity, just kind of a rough sensitivity around that level of inequality. So, here is some different values of that Gini coefficient. This is from the BEMS, a lower Gini, so more equal distribution of resources and less equal distribution of resources. And we found that that shape of inequality was really important for how our model performed. At these higher levels of inequality, we were able to reproduce our patterns with about 80% success across our parameter space. When we had a Gini of 0.25, the model did significantly worse at reproducing those patterns. So, what this told us is first, yes, a simple economic model can reliably reproduce known patterns of migration. And secondly, we had this kind of unexpected finding, which is one of the benefits of ABM, which is that this distribution of inequality in land ownership was very important for how well our model performed. So, briefly, as I mentioned, we did want to kind of take this beyond the simple utility maximization, in part because we know that migration decisions are not actually a cost benefit, right? I spent a lot of time convincing you that it's complex and personal. So we wanted to try a different decision making strategy within the model. We turned to the theory of planned behavior, which I'm sure many of you are familiar with. So, here, a decision or a behavior is influenced by multiple factors. One is attitudes, subjective norms, and perceived behavioral control. So, these three factors come together to influence an intention to take a behavior. That behavior is then based on that intention. So, there are really just a handful of agent based models that use the theory of planned behavior, even fewer in the context of environmental migration. Um, but we wanted to give it a shot. So, a challenge with, as you can imagine, getting more complex into more complex decision making is you have more variables, more decisions and assumptions that have to go into that model. This is how we decided to represent the theory of planned behavior in our model. There are efforts to try to kind of standardize across some of these, which I think would be very helpful because as many models as use the theory of planned behavior, there are just as many ways of actually coding that. But you'll see we have our attitudes, which were influenced by age, perceived utility, social norms were influenced. Now we had network interactions between agents, and then perceived behavioral control, which was influenced by wealth, one's own experience, any past experience with migration, and again, any network experience. So, our intent was a combination of those factors consistent with the theory. And I just want to highlight that within behavioral control, we had these different factors and we had to put weights on those factors. So, how much does wealth matter versus past experience versus network experience? So, I might have lost a slide. Oh, here we go. I jumped ahead a little. So now we have five uncertain parameters. We still have the cost and the utility of our migration, but now we have uncertainty around those weights on each of the behavioral factors as well. So here we could not use the same approach of the support vector machine. So we instead use what's called bump hunting. And this will look in that higher dimensional space for combinations. Again, we're still just looking for combinations of parameters that do a better job at reproducing our patterns of interest. And interestingly, when we look at these combinations of those weights, we found that the weight on our economic variable was the most important. So even with this more complex decision making approach, the model was kind of converging onto a way of decision making that was much closer to the cost benefit. So economics were still dominating in this model. We see a little more variation in these model outputs. Again, we did this sensitivity test around the Gini index. And again, we found that those higher values of inequality did a better job at reproducing our patterns. But in general, the more complex decision making approach did a poorer job of reproducing those patterns across the board. And that's why you see kind of more, this is many, many model runs. So just more variation across that mean. But we still see when we look at pattern one here, some of that kind of nonlinear, maybe initial decline followed by an increase. So we were still able to reproduce those patterns just less consistently with the more complex model. So looking then at our second set of research questions, we found that the theory of planned behavior, at least in our model, did not perform as well as our simple model. So this is, some grain of salt evidence that more complex is not always better. I think especially when you do get into these very complex systems, sometimes just capturing the main driver can do a better job. But again, we found that the land ownership and specifically the level of inequality in the land ownership was really important. So, to kind of bring this together, we did develop this original agent based model. The code is available, it's in Python if anyone wants to take it. I know we've had at least um, one collaborator has taken it and used it in different applications. I'm happy to share that. The pattern oriented approach, along with some machine learning, some kind of careful calibration, can be a good way to evaluate how well our model is doing and to estimate certain parameters that we might not have data for. We started with that simple utility maximization. And a strength, I think, of this model is the flexibility in that we can implement and continue to implement different decision making methods and evaluate the outcomes. And coming back to this inequality piece, so we think there's some implications of that finding that the inequality in land ownership was so important. One is that in this context, at least, we might need to pay more attention to those internal origin socioeconomic dynamics to think about more nuanced policies to address the root causes of some of this migration. And that's important to note that really in this context, I think a goal that we have is to support those who want to stay if they want to stay. And so it seems like to do that, we need to address the underlying inequities in these origin communities. So, potentially, some equity focused interventions could help strengthen these communities and reduce some of that migration pressure. Um, Land rights are a challenge in Bangladesh. They're very weak land rights. And so, there are cases of more powerful households taking over large communities and really dominating agricultural systems and output. This seems to be getting worse with the shift from rice agriculture to shrimp aquaculture. So, thinking about stronger land rights policy reform might be helpful. And then, yeah, as I mentioned, really community led initiatives in the origin. So, some future work. We are interested in continuing to expand the decision making. Like I said, the way the model's set up, we can kind of develop a decision making approach and pretty easily implement it if it's in Python. We're interested in expanding to include potential destinations. We did not at this in this version of the model. A migrant leaves the model and goes to model land. Um, I have been really interested in developing a kind of serious game. So, something that we could actually bring into communities where they could play through migration decisions and really talk us through how they think about those decisions so that we can potentially create a new decision making method informed by that community input. And then lastly, I want to plug we have a new project that is launching, I think, tomorrow called 3MIP. We're calling this 3MIP. It is a mobility and migration model intercomparison project. So, modelers in the audience know we have different MIPs. There's agricultural model MIPs that compare across models, climate model MIPs that compare. We think it'd be really cool because currently we have a lot of different migration models, or at least more than a handful. They use all kinds of different approaches to try to bring them together, compare outputs, find some level of standardization. We think it could make these tools more useful for policymakers and just kind of help us wrap our arms around this complexity. Some questions going forward. I'm just barely scraping the surface here, thinking about migration and non migration, again, with really centering agency in that question. Being in engineering now, thinking about how critical infrastructure and access to infrastructure might affect these dynamics. And then also thinking about receiving communities. And this is something with implications in the US as well. But Bangladesh is really ahead of the game in terms of thinking about where climate migrants might go. So they recognize this pressure on Dhaka, the capital city, which is the primary destination. So there's some really interesting work to actively draw migrants to satellite cities to take some of the pressure away from Dhaka. So they're investing in some of these smaller cities. The idea is that there will be economic opportunities, education, infrastructure to support migrants going into these places. They're even thinking about kind of social conditions, things like prejudice, and trying to create these migrant friendly communities. Here's the plug for 3MIP, as I mentioned, really trying to just start to benchmark these models a little bit better and bring them together. Our test case, our first hackathon, is going to focus on coastal mobility in Bangladesh. That's where I work, and that's where some of my colleagues worked. This is with colleagues at Cornell, Princeton, and Columbia. And then, yeah, thank you, Braden, for plugging my book. I thought I would plug this. It just came out in April, so I'm really excited about it. But this book is a kind of state of the science overview of climate related migration and displacement. So if you're interested, you can find it. It's with Cambridge University Press, or if you want, it's on Amazon too. But all right, so that's all I have, and I'd love to take questions.
Thank you for that talk. That was really interesting. If you wouldn't mind going back to your slide that shows the agent-based model process
Sure.
or the flow, I'm just kind of curious to learn more about how that works. I saw that it decides in the end to send a migrant or not.
Yep.
And I'm curious, is that coming from a household perspective?
Yes.
And not knowing much about climate migration myself, I'm wondering how often is it a decision to send a single migrant from the household versus sending the entire household, and whether it would miss those household migrations?
Mhm. Yes, that's a great question. In this context, I would say it's very context specific. In this context where we were working, it was most commonly sending usually a young male member of the household to the capital city to find work and send those remittances back. That was kind of the most common form of migration. But you're right, in this current structure, it would miss um, cases where entire households were maybe displaced or chose to move. The migration decision here was only based on male migrants as well. So, one part of the evaluation was if there was an eligible member of the household, which was male within a certain age range. Um, Migration is very gendered in this context, so women are more and more migrating. Most of the migration that women undertake is for marriage, and that was not something that's included in this model. But we do, one of my colleagues, Amanda Carrico, who did the household survey data, is now has a whole student looking at those gendered dynamics. Yeah.
Um, just saying. Can you talk a little bit more about the history of land tenure reform in Bangladesh? If that's really playing a key role, where does that come from? Where do we stand today in terms of that aspect of the country and the model?
So it's something that we just started thinking about when we got these results, and we're trying to kind of make sense of it and bring it back to the context. Um, there are just really, in these rural cases, especially, there's not really strong codified land rights. So even being there, we would hear from people who the government would maybe just seize their land in some cases if they wanted to build an infrastructure project, they wouldn't be compensated. And then you would have cases of kind of powerful households who would take over and really have these larger scale agricultural dynamics, which would just shift that inequality significantly. Um, in terms of any recent changes, I'm not familiar with them. There was just a major change in their government last summer. It seems, as an outsider, talking to colleagues there, to be shifting towards something that looks more democratic. At least that's the hope. So I'm not sure kind of where land rights fall in there. Yeah.
Hello, behind the pillar. Thank you so much for this. Yeah, I think I have a similar question. I'm curious how EVM factors in. Like, we can also imagine households might diversify their risks, right, and
Mhm.
send one household member to Dhaka and another outside of the country. And then they're also contributing remittances, which would update wealth. So yeah,
Yeah.
curious how you consider
Yeah.
the like these people might actually disappear from the data set, but they're still contributing to the wealth dynamics.
Yep. So the model does not include international migration, in part because, again, in this context, the vast majority of the migration trips are internal within the country. But international migration, it seems to be increasing. It is a huge source of remittances. I know, for example, during kind of the height of the pandemic, when things were shutting down, huge parts of Bangladesh were really feeling that pain just from not having those remittances coming in. I want to say it's like 6% of the GDP. It's significant. So not in the model, but certainly really important. And so one thing when I think about like a model like this, I think it's kind of a small piece of understanding these processes. So I have other work that is just much more looking at the surveys, using different approaches. Um, I've become, I think, more cautious about using these models just in my own experience with them. And I think we need them with all of the other ways of doing research that acknowledge the complexity and don't reduce it to this. So that's kind of my 2 cents about that. Yeah.
Could you go back to the slide with your two patterns?
Sure.
Oh, yeah, perfect. Um, I was really curious about pattern number two, which is that people from
Mm.
households not affected by the disaster are more likely to migrate. And I wonder what the more likely refers to.
Sure. Yeah. So more likely compared to those who are directly impacted within the same community. So yeah. So within a community, and we had an impact factor that was just the fraction of households that themselves experienced that shock. So the households in a community that does experience a shock, that they themselves are safe, were more mobile than those that were directly impacted. And we think it's a resources thing. So it still takes resources to send a migrant to move. So the household that itself experiences more damage, more impact, might not have those resources in the short term at least to send a migrant versus with the labor market. So the kind of the labor market of the community is impacted. So the household that might still be seeking employment within that community, they themselves aren't impacted, might go elsewhere. Yes. Yeah.
Thank you so much for sharing your amazing work. This is so cool to see a methodologist bring in so much theory. So I just wanted to ask two things and maybe make a comment also on your pattern too. So my question was thinking about this threshold of 20%, right? 20% of folks have to be impacted in order to see an increase in migration. So as a person thinking about environmental migration globally, what kind of events would we expect to impact 20%? Are these common? Are these like the tsunamis that make the world news, or are these actually like floods that happen every summer? So just kind of contextualizing like, is this pattern big or is it?
Great question.
And then to your second point, something that I thought might also explain pattern two is that within a community, of course, where people live within the community, it also informs their vulnerability to being impacted by these events, right? So if you're on the shoreline versus a mile away from the shoreline, you might still be in the same community, but you may be slightly protected in some way. So that pattern, I guess, didn't surprise me, but it's really, really interesting to see you model it.
Yeah, that's a great point. Two really good questions. So the 20%, that would be, I would say, kind of a moderate event. So it's not the massive cyclone, it's not a tsunami you mentioned, but it would be like a significant flood event or a significant drought that does have at least the extent of disrupting that labor market. Of course, we expect those level of events to become more frequent, right? And I think, something that's not captured in the model is if, and in the data that we use to identify the patterns, is if you get a different shape above a certain threshold, right? To your point, I think if we were looking at a cyclone, this would be a completely different set of dynamics. Yeah.
For pattern for pattern 2, I was thinking that people can't give up their people when they're more impacted by the disaster, that they're sad, they need their family members for support and to help rebuild. So I was thinking it's not that surprising because they need each other.
Yeah, that definitely could be part of it. Yep.
Hi there. Thank you so much for presenting on your work. I've obviously do not have as much familiarity with Bangladesh and migration in Bangladesh, but I do know that in West Bengal and in the Seven Sisters, a lot of similarly environmental incidents are complicated, and migration are complicated by tenuous migration status, especially in those areas. There's a lot of migration courts because there's no official definition for citizenship in India. Is there a similar kind of dynamic at play in Bengal? Would these kind of whether the borders are more porous or kind of people's migration status is more questioned? I'm just not familiar.
So, right, I mean, you touch on kind of getting into the history, right? Like ethnically, historically, no major difference between West Bengal and Bangladesh. The history is really fascinating and devastating with partition. Great example of colonial forces coming in and really messing things up. So, with partition, there was mass migration where people essentially picked a side of that boundary. There is still, or at least until recently, there was still pretty common migration from Bangladesh to India and back, especially along those kind of border areas. My understanding is that the Indian government specifically has really hardened that border so that it's much more difficult. This question of statelessness that I know is a really big issue in those parts of India does not seem to be an issue in Bangladesh as much. It, I think, comes from the government and the forces in India specifically. But yeah, the geopolitics of this are also so complex. There's a dam project in India that is likely to majorly disrupt the Ganges and these river systems. Um, yeah, it's a good question. The statelessness issue is not as much of a challenge in Bangladesh.
Thank you so much Kelsey, it's so interesting how you're using the agent-based models and the qualitative methods. And so, yes, thank you so much for the talk. Very interesting. I had a question about the theory of planned behavior that you're using. Can you go back to the model where you list the variables? Okay. So, okay, so the perceived behavioral control. So this model was created by psychologists, and the critique of this model by social epidemiologists is that it does not take into account structural factors. And so I think what you're seeing, this model doesn't work very well because the structural factors are what is really predicting migration,
Yep.
which is heavily influenced by by structure and inequality. So the other thing is that it's interesting. If I understand what you're doing, you're using the variables to predict those constructs. You're using predictor variables to predict those constructs. Like, for example, instead of using a social norm variable, you're using a proxy variable of peer choices in the network.
Yes. Yep.
Okay. So you're not using the actual, you're not use most psychologists use variables where they measure the social norm. They measure the behavioral attitudes. So the psychologists, they measure something that is like one step removed from the behavior that you're doing.
Yes,
So if
yes.
they want to measure whether you're going to wear your seatbelt, they're going to ask, what is your behavioral attitude towards wearing a seatbelt? And what do your friends do when they wear their seatbelts? And what are the behavioral problems about wearing the seatbelt? So you're just moving one step backwards,
Yep.
which is not that interesting in my opinion
Uh-huh.
about how you predict about what's wearing the seatbelt without, measuring the structural issues. So also, you don't have some of the norms that are measuring what the intent of Asgen, one of the original creators of the model, is around the explicit social norms around migration. Like, what are the norms in the village around migration?
Yeah.
Or what are I don't know, but perceived behavioral control, I would imagine, would be around those are just proxies that I don't think are capturing some of the norms around what the family believes,
Yes.
might be real perceived behavioral control. So I think that could also be what's contributing is that those aren't getting at the true constructs of what might predict
I think
what's
that's
going
a
on in the
great
model.
point. Yeah. And a lot of these decisions were because of the data we had in the household survey. I would love to go back and ask really specific questions around this theory about migration intents. Um, we talked to a lot of people, our colleagues there, to try to inform this as much as possible. But yes, absolutely. And I think, as I mentioned, it's a huge challenge with trying to implement a framework like this into a simulation model. You ultimately have to put it into some simplified equation that you may or may not have the right indicators for. Um, Part of the exercise of this, I thought this would do better before I just intuitively before I actually started implementing it. Um, but most models out there will just pick a decision making approach and present those results. And so we really wanted to also kind of be teasing apart like the way you implement a decision making strategy in your model makes a huge difference in the model output. The huge critique of these kinds of models is that decision making decision really matters.
All right. So let's thank Dr. Best. Thanks so much for giving your talk today.